This tutorial extends the idea of line fitting and quadratic fitting to a polynomial fitting. So that means we have a function where we could have various powers of x with coefficients, and again our goal is, given observations of x and y, we need to find all the coefficients a, b, c, d, so on and so forth. So in this case, you can extend the idea of the linear and polynomial fit by finding the pseudo inverse, but I will teach you about two functions called polyfit and polyval, and they can achieve exactly the same function that is done by using the pseudo inverse. So again, let's use our observations of x and y from previous problems, but now instead of applying pseudo inverse, what I can do is, first of all, go ahead and look at the help of polyfit and read briefly that it fits a polynomial to data, and then read this description where x and y are the observations and n is the order of the polynomial. So if n is equal to 1, that means it's a line fit. If n is equal to 2, it's a quadratic fit. And in this case, you can have any arbitrary value of n. Something that you have to note here is that p1 is the coefficient of the power, the nth power of x, and the value of last p value is the constant. This is opposite to the way we have written this equation. So d technically would be the first value in p. So you have to be careful when you apply this. So for example, if I want to apply this linear fit, polyfit x, y, and then first order polynomial, you will see that I get the two values. Now when I did the pseudo inverse, this was a and this was b, but when we apply polyfit, this is a and this is b. Now to find the fit value, we just simply call a second function called polyval, and this will find us the fit values for y, and what we tell it is that p are the parameters and x is where we want to find the value of the fit, and it will give us the 5 values of the y fit. Again, we can compare them. We can also look at the error between them, and these are the observations, the model fit, and the error. And we can create the function and plot it just the way we did it in the previous cases. Now let's see if we fit a cubic model. Here is an example of fitting a cubic model which has which will have 4 coefficients. So if we look at the p-values, now again this is a, b, c, d. So this is the coefficient that goes with the cubic power. This is the coefficient that goes with the squared power. This is the coefficient that goes with x, and then this is the constant value. Again, keep in mind that this is the reverse of what we see before. Again, if we plot this, you can see that this will fit a cubic equation into the available data.